So it's great to hear a number of the talks this morning. I think it leads right up to my presentation, which is if you're trying to provide personalized nutrition, you need to know what someone is currently eating. And diet assessment, for those of you who are in that field, know how difficult it is. So I put a little subtitle in there from the standpoint of personalized wellness, because I think that's where we just started talking about is once you know certain things, how can you improve health? So I thought I'd start out by talking about the different techniques that have traditionally been used for doing diet assessment. And there's really four. So food records, someone writing down what they eat, either physically writing down on a piece of paper or using technology, or something called weighed food records, which I think has been more popular in Europe than in the United States. There's also 24-hour diet recalls where a professional interviews an individual and asks that individual on a random day how much did they eat of certain foods the day before. And there's products out there like NDSR, which is from University of Minnesota, that provides a whole series of questions to ask. So if someone says they eat lasagna, then just follow-on questions that talk about the preparation. It's very detailed, takes a lot of time. Then there's survey questionnaires, like food frequency questionnaires, which is a retrospective review of what they're eating, but self-administered. And typically that's been done in paper, on a paper tool where you mark down on a number 2 pencil, scan it in, and get an analysis. And usually done in very large cohorts in the past. And then finally, there's metabolic feeding studies where, in this case, you're not measuring or asking what someone has eaten, but you actually feed someone the food, so you know what they're eating from the standpoint. So there's several problems. Food records, which could be the most accurate on the real-time status, has a big problem because once you ask someone to do something, there's a burden, they'll change what they eat. So if you're really trying to look at correlation of a person's diet to disease, you're going to lose that quality of answers. And it's high burden, so you're not going to ask someone to do that day after day after day. 24-hour recalls and questionnaires, memory recall. It's difficult for someone to remember all these things. So people have been, scientists, software, I'm a computer engineer by training, engineers have been looking at this problem for a number of years, and with the advent of new capabilities, we've been adjusting some of these. So my company is specifically focused on 2 areas that I'm going to talk about today. One of them is a food frequency questionnaire. So we've been working with Dr. Alan Crystal, who's an epidemiologist from the Fred Hutchinson Cancer Research Center, for about 8 years, and his FFQ has been used in the Women's Health Initiative and a number of our other large cohort studies. We've been funded through the National Cancer Institute grant, and what we did was we took the paper form and tried to improve on it using the web. So we took this concept, provided a web interface, and then redesigned the flow of it to make it easy and make it available to individuals. One of the things right off the bat, when you take something from paper and go to the computer, you can stop someone from mismarking. The computer can analyze everything, so we can guarantee that someone goes through our FFQ will be 100% accurate from the standpoint of no mismarked questions and things like that. Alan, who processes at the Hutch about 1 million FFQs a year, has a 5% kickout rate for people mismarking, so it's pretty significant. Another significant issue with any system is the amount of time it takes. So we've designed our system to try to take under 30 minutes. Now it's plus or minus a few minutes, but what we found is that if you get to an hour, again, you start losing the accuracy. People start rushing through and mismark. Our analysis is being used through the NDSR, University of Minnesota's NDSR database, and at least in the United States, that's kind of the gold standard for quality and analytics. And we recently finished a validation study, which I hope to have the final analysis available here, but it's probably another week away. But what we know is that when we studied our questionnaire against 6 random 24-hour recalls, which is one of the standard techniques to measure and validate, our correlation of macronutrients to the 24-hour recall was very, very high, much higher than the Women's Health Initiative. So we're really excited about that. And if anybody is interested, if you can give me your card, I can send you the paper when we're done with it. So a couple innovations that we did using the computer. From what I know right now, we're the first system to actually integrate photos of foods throughout. So one of the issues with doing measurement of portion size is people can't tell you from a standpoint of a cup, at least in American standards, how much a cup is. And I would assume that's probably the same with grams in Europe. So instead of doing that with text, we show pictures, which I'll show you in a second. We also help from a standpoint of comprehension, having thumbnails of images of food so that there's a reinforcement of, did I eat spaghetti? And then there's a picture of spaghetti, so you choose the food. We use complex branching, so depending on what you answer, we may go into a more deep dive into the food itself. We call them adjustment questions. And then finally, because we do it the way we do, we only ask you to answer more questions of foods only that you eat. So if you eat a food less than a month, once per month, it doesn't have a great deal of nutritional composition to your bottom line diet, so you don't have to deal with it. So from a picture standpoint, these are screenshots. So the idea is we took about 400 foods, which is standard for an FFQ, collapsed it down to 125 specific questions, split them up into 19 food groups. So what I'm showing right now is the cereal and breads food group. So we ask an individual to think about the last 3 months, what they ate. So now we're dealing with just a season of foods. Different seasons, people tend to eat differently. And so they push a button, each of these are buttons, for the foods they eat at least once a month. Say they pick cold cereal, and at least in the United States, there are 4 types of cold cereals: sweetened, high fortified, whole grain, and standard cereals. So depending on what you pick there, you'll eventually get to a screen that asks what's the frequency and what's the portion size. Both of these questions, which is only 2 questions, can be customized to each individual food. So there's some foods where we go up to as many as 9 images for portion sizes. And again, we're trying to focus an individual. You may say, well, why not have 9 images for every single food? You add more pictures, you add more comprehension, more cognitive work has to go on. So you try to keep it to just the minimum to get the most accuracy. But again, here's an adjustment question. Because most people have milk, but not always, we want to know whether you do add milk to the cereal, and what kind of milk, and how much. And again, just as another example, spaghetti to me is the typical example I give in the United States. Very hard for someone to tell you how much spaghetti they eat. And there's a lot of fast food Italian restaurants in the United States, a big chain called Olive Garden, and they serve a very large amount. And I'm confident that someone who goes to an Olive Garden would not be able to accurately tell you how much they ate. But if they saw these series of pictures, they most likely would pick something like that when they go to Olive Garden for spaghetti. And the result, after 27 minutes, immediately we have available an analysis. So from a research standpoint, there is a way to export the data and generate about 150 different nutrient components of the analysis, and we average it out to a daily analysis. On a consumer side, we generate a couple different reports. One is a simple 1-page consumer-friendly report, and then we have a more extensive report that could be used by a coach or a dietitian. On the more extensive report, we can sort foods by a nutrient. So one of the typical examples I talk about is if you have a patient or a client that has high LDL, then saturated fat and total fat is an important aspect of the person's diet. We can tell you what foods contribute most of the saturated fat in that person's diet. So now you can start coaching against those specific foods. So you get very personalized now. Instead of you eat lower fat to lower your LDLs, fried chicken, ice cream, and chocolate are your highest fat sources. So now we can talk about changing behaviors right there. And ideally, you don't want to deprive someone of something that they want to eat. Again, in the United States, in the South, fried chicken may not be something that an individual would be willing to give up. So instead of forcing them to change fried chicken to broiled chicken, you move to ice cream and say maybe they'll convert from full-fat ice cream to frozen yogurt. So moving on to another technique. This is now a food record system, and it's based on the idea of a mobile food system. So instead of burning someone with writing down on paper what they're doing, and I think there were a couple of talks that talked about taking a photograph. So this is the same kind of capability, but instead of just taking a photograph, we're taking the photograph and using image recognition to identify the food and the portion size automatically. So the idea is pretty much everybody who has a mobile phone has a camera. Almost everybody, at least in the United States, I would imagine the same in Europe, carries a mobile phone today. So it's a pervasive technology available to do many things. People more and more are using it for many, many things. And by taking advantage of the capability of a mobile phone, we think we can provide a great user experience, low burden, fast, inexpensive way to accurately, real time know what someone's eating. So this is a model of the system. So the idea is, in our case, we're taking a series of photos right now. Eventually, we'll move into a video, and that really is linked to the carrier capability. In the United States, we're just moving to 4G, so we have the bandwidth. We also add right now a bit of speech recognition, so that it enhances the recognition, but we're working on reducing that requirement. We take those images, and what we do is then look at the picture, look for the plate on the picture, and then segment that image into different blobs of food, basically, and then do classification. From the different blobs, we can then create three-dimensional images, do a volume estimation, go look up in a database those foods, the volumes, and convert that into a nutritional analysis, provide that to the researcher, the clinician, and maybe back to the individual if you're trying to do an intervention. So to get in a little more detail on the segmentation classification, so what we're trying to do is say, if you can look at a plate and know all the pixels in the plate and associate it together, then you can use things like texture, color, and shape. Because if you think about it, you can recognize a food pretty well, right? If you look at a plate and see green beans or corn or mashed potatoes, you're able to see it because you see the differences between the three different segments of the food. So we're trying to do the exact same thing. We're saying, let's put a border around each of these segments, and then when we do this three-dimensional image, we can create the volume from it. And so there are problems. This is not a perfect engineering solution yet, but we've gotten to be pretty accurate at being able to do that. But some foods, actually I'll take the worst case, some foods like soup, can't see inside. So if you have a soup that's a black bean mixture or a casserole, you have to get more information from the individual. Now we're lucky enough that from the grant that we have, we're working directly with NIH on this, and we have access to a program from USDA called NHANES that does, it's called AMPM, but it's worked in the NHANES program, which is a national survey of food. And they've worked out all the details that says, back in the 24-hour recall idea, if someone says lasagna, then you have to ask certain questions. Now, from the standpoint of classification, we have to have a database that has a food picture, at least one picture of every food, so be able to compare it. If you're familiar with speech recognition, we're actually scoring the image against a database and doing a classification, a classifier, and being able to analyze it. And so as we build up the database, we'll be able to classify more and more foods. So getting back to pictures and more examples. So this is an example of our second generation segmentation. So in the beginning, when we first started doing it, you could see it was a little bit rougher around the strawberries. But now with the added knowledge of classification, we know strawberries and we have to really put a nice tight image around it. Now one of the issues with both classification and segmentation, we still have troubles with like seeds on the strawberry. Is that seed actually part of the strawberry or is it a separate food? Or what about poppy seed on a bagel? Is it go through the bagel or is it just a speck on top? So there's very, very interesting engineering problems about this whole classification. But on the portion size estimation, we use this 3D image. We actually ask people to take before and after images. So there's a bit of a burden there, but you need to know what they ate total, not what they intended to eat. So we also ask people to put down what's called a fiducial marker. And this is a little square of black and white information, a grid, and that gives us a distance, because depending on where they take the picture will change the distance, and we want to be accurate. So here's a specific example. Now you can see here's the fiducial marker. In this case, we've used a color and a black and white. We've gotten rid of the color in the recent past. So eventually that will be a credit card size kind of grid. So there's all these 5 pictures are slightly different. You can see there's a slightly different angle. Doesn't have to be much. This is probably more than it has to be able to create the 3-dimensional image. So here's how we've segmented. Down here is the 3 different volumes, 3-dimensional vision, and then we convert those into volumes. Now one of the issues about volume in the USDA database is that not all foods and we're using a USDA database, not all foods in the USDA database have volume measurements. Most of them, all of them have grams, but there are missing foods that are missing volume, so we're working with another organization on that. We started off with a Nokia Symbian phone, but most recently started migrating into a smartphone. We're starting off with an Android phone, and eventually we'll go to an iPhone. So this is in development now. It's not done, but we've been able to at least do some analysis on the identification and on the volume. So we did a small test on the volume, and we can go from anywhere from 85 to 90% accuracy on known foods with known truths against what we've analyzed for. So we're really excited about that, and we think we can continue improving on it. So from our standpoint, the last area of topic that I'll go through is we actually license this technology, but we also have embedded into a system for wellness, and we call it VioWell. So the idea, I think was talked about before, is that you want to measure or assess where someone starts. You want to create a mechanism, in our case we call it a plan or a set of goals, and put them through, identify a wellness plan, and then be able to monitor or track what they're doing. So VioScreen, which is our FFQ, is part of this assessment. We also do a physical activity assessment, and something we call the Living Well Navigator, which is a unique tool that addresses barriers. So it's great to know what someone is eating, what someone should eat, but from a behavior standpoint, if someone has a barrier and you don't address the barrier, they may never change their lifestyle. So we think that's an important aspect. We did this work with Dr. David Katz from Yale University, and we identified 147 barriers to dietary and physical activity change. Pretty significant, and what we found is the result of the barrier analysis, we actually generate a custom set of resources and tools to the individual that can actually be customized to the community that they're at. So 20-some of these barriers can actually be connected back to the local community. From the standpoint of the next step, then we create a plan. We like the idea of having someone with a coach, and so the idea that the plan would be developed by a coach in an interactive phase. First plan would be the most time-consuming. Follow-on plans would take 5 minutes to review. So someone would go off 2 or 3 weeks, work on their plan, come back and talk to the coach and say, what worked, what didn't work, do we have to tweak the goal, is there anything that we need to change, and then send them off and do more. And be able to see all the information that's going on. This is an example of the wellness plan. And then the tracking. So this is where food tracking would come in. The FIVR, or we call it VioLog, the mobile phone, will be added here. But we also have weight tracking, physical activity tracking, and more barriers. So this is a back-end screenshot of the food tracker. I don't have the images here yet, but the idea would be, in addition to the food records, a researcher or a clinician would be able to actually see the images, be able to see the text that would be from the speech recognition, actually hear the sound that actually would be associated with it. And in times where there would be difficulty on actually analyzing the image, if you have the image, then someone in the back end can manually go in and interject and enter the foods directly. It's an example of the activity tracker. Now, there was a couple examples of Direct Life and Fitbit and some other tools for accelerometers. We actually interfaced with a product by Omron. They have a pedometer that has a USB port. One of the nice things about it is that on Amazon it's $29. It still uses an accelerometer, and when you connect it up to your computer, it automatically updates, goes right into our system and with the number of steps. And steps is a great way of promoting more physical activity. And then finally, we also took into account the idea of social networking. So we have a community program that we developed on another grant that we call Princeton Living Well, but the idea of this community social networking component was that people really like interacting with other people. And one of the unique things about this was not only to get people connected into the community with other people, but we created a rewards program that's fairly unique. The rewards program was actually provided by local retailers. So we gave people points for doing things healthy, online and offline. So if they tracked their physical activity, they got points. If they did steps, they got steps per point. They could actually go off to a local community educational program and also get points. But when they collected enough points, there was an online catalog that could give them discount on their local groceries. And right now we're talking to a restaurateur in Princeton that has 4 restaurants, which we work with. They give discounts for their food, but we want to now localize it to the point that the discount actually goes to only specific healthy menu options. And so that's the next step. And we're now using a tool on a mobile phone again that uses GPS to locate someone at the restaurant and tell them what to eat at that restaurant off the menu. So that's another one for maybe another topic. So I think with that, I thank you for listening to me.